Sadie's calibrating the grain drill.
Okay, so today we're trying to figure out how many pounds of seed this drill is putting out per acre. We're going to do that by looking at 1 pound of seed and seeing how much area that seed covers. So the first thing we're going to do is figure out how to measure how far our drill is traveling at a time. So we want to get the area around our wheel. We do that by taking the diameter of the wheel, which in this case is 28 inches, and multiplying that by pi, so we get the full distance around the wheel. In this case, that is 88 inches. We then are going to so every time that the wheel rotates, it is moving forward by 88 inches. We also need to know how far across the seed is being spread. So in this case, our drill is 10 feet long, but we don't want to practice with the whole 10 feet. So we're going to use just the first 4 holes, which in this case is 2 feet or 24 inches. So now we know that every time that this tire rotates, as marked by our chalk here, it is moving forward 88 inches and across 24 inches. So the area of that is 88 times 24. So 88 times 24 gives us 2,112 square inches, which we want to now think about that in feet. So we're going to divide that by 144 square inches, giving us 7.6 square feet. Actually, 14.6 feet squared. So every time that this tire rotates, one full rotation, we're moving 14.6 square feet. I'm going to take my 1 pound of grain. I'm going to put in these first 4 holes, the first 24 inches like we talked about. I'm going to space it out pretty evenly so that it flows out. So now my 1 pound of seed is inside the drill, and I'm going to rotate the tire, counting the number of rotations that it takes to fully empty the drill. So to show that, here's my mark. As the mark passes back down, that's 1 rotation. And I'm going to count that until the drill is empty. Okay, so we're at a seed, and it took us 28 rotations. So in order to figure out the area covered in square feet, we're going to take that number, 28 rotations, and multiply it by the area covered by 1 rotation, which we already did at the beginning. That's our tire, 88 times, sorry, not 88. This is our 14.6 feet squared. That gives us, what you'll remember was our tire, which was 88 inches, and our width 24 inches, which we then converted to feet, 14.6
Square feet.
Square feet. So then we take the number. So now we have the area covered by 1 rotation. Multiply it by the number of rotations that we got, 28 in this case. We get our total area covered in square feet, which was 408.8 feet squared. Now you remember, we're working just 1 pound of grain. So that is saying for 1 pound of grain, we have covered 408.8 feet squared. Now, if we want to figure out per acre, we need to get rid of our feet squared. And we do that by knowing how many feet squared are in an acre. There's 43,560 feet squared. So if we were to multiply this across, our feet squared cross out, giving us pounds per acre. Pounds per acre. So that will be feet squared over 1 acre. We get 43,560 over 408.8. We'll divide those two to give us pounds per acre. In this case, 106 pounds per acre. So going forward, now you know, in order to find out how many pounds per acre, you're just going to take 43,560, the area within an acre, and divide it by the area you traveled in your test run. So at this setting, we got 106 pounds per acre. If we wanted, if that was too much or too little, we could then change the settings on our drill and do the procedure again to figure out how many pounds per acre at a different setting. You'll notice that we have our wheel jacked up so that this spins freely, and we have a tarp underneath to collect our seed as we do our practice, our calibrations.